has been in my family for generations. Another says, no, your grandfather sold it to my father. There are no official records, just memories and maybe some faded papers that could be forged. So the village comes up with a clever solution. They create a special ledger book, but not just any ledger. This ledger has three important rules. Rule 1. Every time someone buys or sells land, the transaction gets written on a new page of the ledger. Rule 2. Before the page gets added to the book, 10 randomly chosen villagers have to verify that the transaction is legitimate. They check: does the seller actually own the land? Is the buyer paying a fair price? Are both parties agreeing voluntarily? Rule 3. Once verified, the page gets added to the book. But here's the clever part. Each new page includes a tiny snippet of information from the previous page, like a unique fingerprint. If someone tries to go back and change an old transaction, they'd have to change that page's fingerprint, which would break the connection to the next page. And they'd have to change every single page after it. And since copies of the ledger are kept in 10 different houses around the village, they'd have to break into all 10 houses and change all 10 copies simultaneously. That, in essence, is what a blockchain is. It's a digital ledger with those same three principles. 1. Transactions are recorded but digitally, and they can be anything of value, not just land. Multiple computers verify each transaction before it's added. This is called consensus. 3. Each block is cryptographically linked to the previous one, creating a chain that's virtually impossible to alter. Now, let me give you the technical definition. Now that you have the analogy, a blockchain is a distributed, decentralized digital ledger that records transactions across many computers in such a way that the registered transactions cannot be altered retroactively. Let's break down those keywords. Distributed. Instead of one central ledger, like a bank's database, copies exist on thousands or millions of computers worldwide. These are called nodes. Decentralized. No single person, company, or government controls it. Control is spread across all the participants. Digital ledger, it's a record keeping system, but digital, cannot be altered retroactively. Once something is recorded, it's extremely difficult to change. Not impossible theoretically, but practically and economically infeasible. Why does this matter? Because for the first time in human history, we have a system for recording and transferring value that doesn't require trusting a central authority. You don't have to trust that the bank will record your transaction correctly. You don't have to trust that the government won't seize your assets. You don't have to trust that a company won't change the rules. The trust comes from mathematics and network consensus. It's trust through transparency and cryptography, not through institutions. Let me give you a modern example. Imagine you want to send money to a family member in another country. Today, you might use a bank transfer that takes 3 to 5 business days, costs $25, $50 in fees, requires both of you to have bank accounts, could be frozen or reversed by the bank in, involves sharing sensitive personal information with multiple intermediaries. With blockchain, that same transfer could take 10 seconds to 10 minutes, cost pennies in fees, work for anyone with a smartphone and internet connection, be irreversible once confirmed, protecting against fraud, be pseudonymous, no need to share personal details. But here's what most people miss: blockchain isn't just for money. That same technology can be used for supply chain tracking, proving your coffee is truly fair trade; digital identity, controlling your own personal data; voting systems, transparent, tamper proof elections; property records, no more lost deeds or title disputes; medical records, secure, portable health data. Now, I want to address a common misconception. Blockchain is not the same as Bitcoin. Bitcoin is the first and most famous application of blockchain technology, but blockchain is the underlying technology that enables Bitcoin and thousands of other applications. Think of it this way: email is an application that uses the internet. The internet is the underlying technology. Similarly, Bitcoin is an application that uses blockchain. Blockchain is the underlying technology. One more crucial point: not all blockchains are the same. Just like there are different types of databases, some for simple websites, some for complex banking systems, there are different types of blockchains optimized for different purposes. Bitcoin's blockchain is optimized for security and decentralization as digital gold. Ethereum's blockchain is optimized for running smart contracts, which we'll cover soon. Solana's blockchain is optimized for speed and low cost transactions. Private blockchains are used by companies for internal record keeping. Public blockchains are open for anyone to participate. The choice of blockchain depends on what you're trying to achieve. It's like choosing between a pickup truck, a sports car, or a minivan, different tools for different jobs. Now, you might be thinking, this sounds great, but what about the environmental impact I've heard about? That's an excellent question, and it shows you are thinking critically. The truth is, it depends on the blockchain. Early blockchains like Bitcoin use a lot of energy because of their proof of work consensus mechanism. But newer blockchains like Solana use proof of stake, which is about 99.9% more energy efficient. Ethereum recently switched to proof of stake, reducing its energy consumption by over 99%. So the environmental concern is real for some blockchains, but the technology is rapidly evolving to address it. Let me leave you with this thought: blockchain solves a fundamental human problem, the problem of trust between strangers. For thousands of years, we've relied on intermediaries, kings, banks, governments, corporations to establish trust in transactions. Blockchain offers an alternative: trust through transparent mathematics rather than opaque institutions. Whether that's ultimately better is still being determined, but understanding how it works puts you in position to make informed decisions about participating in or building the future. In our next section, we'll explore how blocks actually work and get into the fascinating world of cryptography that makes all this possible. 1. Blockchain properties. Detailed explanations of security, transparency, and immutability with multiple real world examples. 2. How blocks work. Visual walkthrough with animated metaphor of digital Lego blocks that chain together. 3. What are nodes? Explanation of network participants with analogy of notary publics in digital space. 4. What is consensus? Deep dive into different consensus mechanisms with sports refereeing analogy. 5. Public versus private blockchains, comparison with public parks versus private clubs, metaphor. 6. Blockchain use cases, 5 detailed examples including supply chain, voting, identity, etc. 7. Smart contracts, comprehensive explanation with 7 different real world application examples. 8. Why smart contracts matter. Historical context from traditional contracts to digital automation. 9. DApps, decentralized apps. Comparison with traditional apps using restaurant versus community kitchen analogy. 10. Example: smart contract flow. Step by step walkthrough of if then logic with visual aids. 11. Smart contract advantages. Focus on instant execution, global access, permissionless nature. 12. Limitations. Honest discussion of code errors, network fees, irreversibility. 13. Blockchain summary. Visual recap with trust, security, transparency framework. 14. Web3 summary. User ownership plus decentralization equals new internet paradigm. Now that we understand blockchain technology, let's explore its most famous application, cryptocurrency. I want to start by correcting a common misunderstanding. Cryptocurrency is not internet money or magic internet beans. It's something much more profound and practical. Let me give you an analogy that I think will change how you think about cryptocurrency forever. Imagine you are at an international airport. You have dollars, but you need euros. You go to the currency exchange booth. What happens? 1. You hand over your dollars. 2. The clerk takes a hefty fee, let's say 10%. 3. They check multiple IDs and forms. 4. They might ask what you need the euros for. 5. They record your transaction in their private ledger. 6. They might report it to the government if it's over a certain amount. 7. Finally, you get your euros minus their fee, minus their spread, minus their compliance costs. Now imagine an alternative. You have a special app on your phone. You enter that you want to exchange $100 for euros. You hit send. Instantly, the equivalent amount in a euro pegged digital currency appears in your European friend's digital wallet. No questions asked, no IDs checked, no forms filled, and the fee about 10 cents instead of $10. That's what cryptocurrency enables, peer to peer value transfer without intermediaries. But let's get more precise in our definition. Cryptocurrency is digital. It exists as code, not as physical coins or bills. Decentralized, no central bank or government controls it then. Secure, protected by cryptography, hence crypto plus currency. Transparent, all transactions are visible on a public ledger. Borderless, works the same in Nigeria, Norway, or Nicaragua. Permissionless, no one can prevent you from using it with some regulatory exceptions. Now, here's what most beginner explanations miss. Not all cryptocurrencies are trying to do the same thing. This is like saying all vehicles are the same when we have bicycles, motorcycles, cars, trucks, and airplanes. Different cryptocurrencies serve different purposes. Bitcoin is like digital gold. It's designed to be a store of value like holding gold bars, a hedge against inflation, limited supply of 21 million, a settlement layer for large transactions, simple and secure above all else. Ethereum is like a global computer. It's designed to run smart contracts, self-executing agreement, host decentralized applications, enable complex financial products without banks, be programmable and flexible. Solana is like the high speed rail of cryptocurrency. It's designed for lightning fast transactions, 65,000 per second versus Bitcoin 7, extremely low fees, pennies instead of dollars, mass adoption and everyday use, supporting complex applications at scale. Stable coins like USDC, USDT are like digital dollars. They are designed to maintain one-to-one value with traditional currency head, provide price stability for everyday transactions, enable easy entry, exit from cryptocurrency, serve as a bridge between traditional finance and crypto for understanding these differences is crucial because it helps you avoid the mistake of thinking all crypto is the same. It's like understanding that you wouldn't use an airplane to go to the grocery store and you wouldn't use a bicycle to cross an ocean. Now let's address the elephant in the room. What gives cryptocurrency value? This is where many people get confused. So let me break it down simply. Cryptocurrency has value for the same reasons. Anything has value. Mine, scarcity. Most cryptocurrencies have limited supply. Bitcoin will only ever have 21 million coins. Scarcity creates value. Diamonds are valuable partly because they're rare but yet scarce. 2. Utility. Cryptocurrencies enable things that weren't possible before. Ethereum enables smart contracts that automate complex agreements. This utility creates value. 3. Network effect. The more people use a cryptocurrency, the more valuable